Hi guys, welcome to your lesson on lifespan and childhood development. This is the first lesson in our unit on developmental psychology, which is such a great unit. It's so much fun. We will be reviewing some things, many things actually, from past units. So keep that in mind as you start making connections with old stuff and the new stuff that we're learning. So what is developmental psychology? It's a branch of psych that studies physical, cognitive, and social change throughout the span of life. So we're going to be looking at infants and childhood, we're going to be looking at adolescence, and we're going to be looking at adulthood through the lens of physical, cognitive, and social changes throughout the lifespan. 3 issues that have engaged developmental psychologists are nature and nurture, continuity and stages, and stability and change. So nature and nurture, how does our genetic inheritance, nature, interact with our experiences, nurture, to influence our development? Continuity and stages, what parts of development are gradual and continuous, and what parts change abruptly in separate stages? And stability and change, which of our traits persist through life, and how do we change as we age? Tip number 1, all 3 of these issues, nature, nurture, continuity, stages, stability, and change, are important for development. Nature and nurture, of course, weave their way through almost every module. Look for the nature-nurture idea throughout whenever you're referencing the text, and it will definitely be on the AP exam. How do genes form our nature? So the gene combination created by the merging of our mother's egg and our father's sperm helped form us as individuals. Genes predispose both our shared humanity and our individual differences. How does our environment shape our nurture? So our experiences also form us in the womb and in the world. Even differences rooted in our nature may be strengthened by our nurture. We are not formed by either nature or nurture, but by their interrelationships, their interaction. Biological, psychological, and social cultural forces interact to shape our nurture and our nature. So how does growth happen continuously or in stages? Do adults differ from infants as a giant redwood differs from its seedling? A difference created by gradual cumulative growth? Or do they differ as a butterfly differs from a caterpillar, a difference of distinct stages? How do stage theorists view development? Well, stage theorists, we have Lawrence Kohlberg, Erik Erikson, and Jean Piaget. Stage theorists who emphasize biological maturation tend to see development as a sequence of genetically predisposed stages or steps. Although progress through the various stages may be quick or slow, everyone passes through the stages in the same order. So we're going to be going more in depth on each of these 3, but Lawrence Kohlberg, which we have Kohlberg's stages posted in almost every classroom at Williams, these are the levels of moral development. Erik Erikson is psychosocial development, and Piaget is cognitive development. And each of them have different stages in those 3 types of development. What evidence supports the theory of stable development over time? So one research team studied that 1,000 people from ages 3 to 38 was struck by the consistency of temperament and emotionality across time. Out of control 3-year-olds were the most likely to become teen smokers, adult criminals, or out of control gamblers. What additional research on nature versus nurture exists? In another study, 6-year-old Canadian boys with conduct problems were 4 times more likely than other boys to be convicted of a violent crime by age 24. Can temperament predict divorce? In one longitudinal study of 306 college alums, 1 in 4 with yearbook expressions like the one in the left later divorced, as did only 1 in 20 with smiles like the one on the right. Now that doesn't mean you're going to get a divorce if you're not super bubbly in your yearbook picture. These are just what's one longitudinal study of 306 people. So not a very big sample. And the results do show a difference. So are people's personalities mostly stable over time? As at 70, so as As at 7, so is 70, says a Jewish proverb. People predict that they will not change much in the future. In some ways, they are right. As people grow older, personality gradually stabilizes. But do we change too, right? Or we do change too, right? Our social attitudes, for example, are much less stable than our temperament, especially during the impressionable late adolescent years. Older children and adolescents learn new ways of coping. Although delinquent children have elevated rates of later problems, many confused and troubled children blossom into mature and successful adults. So just because you're struggling now or you struggled in upper L or middle school or anytime in high school, it doesn't mean you're not going to blossom and move past those issues into mature, successful adults. Are both stability and change important? Well, life requires both stability and change. Stability provides our identity, enabling us to depend on others and on ourselves. Our potential for change gives us our hope for a brighter future, allowing us to adapt and grow with experience. That's why in Montessori we have lots of things that are stable. Prepared environment, we have lots of different things in that are stable. We also very much depend on life lessons throughout our day and at camp and on intercessions that allow us to adapt and grow and deal with change, because part of life is dealing with change. So tip number 2, almost every topic in psychology holds personal relevance, but development stands out. As you work your way through this unit, think of how the material relates to you, your relatives, and your friends. The more often you do this, the easier it will be to remember the material. The material you learned back in the learning module about making material personally meaningful enhances processing and later recall, as you learned in the memory unit. So what's the course of prenatal development? Life begins at conception and continues through several stages in the womb. Conception occurs. The path to life begins with the release of an egg from the mom's ovary. 250 million deposited sperm approach an egg cell 85,000 times their own size. The small number reaching the egg released digestive enzymes that eat away the egg's protective coating. One sperm penetrates the coating and enters through the egg's surface, blocking out the other sperm. Within hours, the sperm nucleus and the egg nucleus and the sperm nucleus fuse. The two become one. So the two nuclei fuse together, becoming one. The germinal stage, which is the first 10-day to 2 weeks of development, is when the fertilized egg, called a zygote, undergoes rapid cell division. One cell becomes 2, then 4, each just like the first, until the cell division produces some 100 identical cells within the first week. We're talking meiosis here. The cells then begin to differentiate, to specialize in structure and function, to become brain tissue, intestine tissue, heart tissue, etc. How does the zygote become an embryo? So, about 10 days after conception, the germinal stage completes as the zygote attaches to the mother's uterine wall, beginning approximately 37 weeks of the closest human relationship. A healthy and well-nourished mother helps form a healthy baby-to-be. Over the next 6 weeks, the embryo's organs begin to form and function. The heart begins to beat. How does the zygote become an embryo? Continued. The zygote's inner cells become the embryo. Many of its outer cells become the placenta, the life link that transfers nutrients and oxygen from mother to embryo. How does an embryo become a fetus? By 9 weeks after conception, an embryo looks unmistakably human. It is now a fetus. Fetus is Latin for offspring or young one. During the 6th month, organs such as the stomach develop enough to give the fetus a good chance of surviving and thriving if born prematurely. And in the fetal stage, by the start of the 9th week, when the fetal period begins, facial features, hands, and feet have formed. As the fetus enters the 16th week, its 3 ounces could fit in the palm of your hand. What does research show about the development of language in the womb? After repeatedly hearing a fake word, ta-ta-ta, in the womb, Finnish newborns' brainwaves displayed recognition when hearing the word after birth. If their mother spoke 2 languages during pregnancy, newborns displayed interest in both. And just after birth, the melodic ups and downs of newborns' cries bear the tuneful signature of their mother's native tongue. What are teratogens? Literally monster makers, agents such as chemicals and viruses that can reach the embryo or fetus during prenatal development and cause harm. If you've taken AP Environmental, you know that we studied these and carcinogens in several of the different units. So examples of teratogens: alcohol consumption by the mom, tobacco use by the mom, drug use, cocaine, meth, etc. by the mom, viruses contracted by the mom, and certain medications taken by the mom. How does alcohol impact the fetus? You shall conceive and bear a son, so then drink no wine or strong drink. A pregnant woman never smokes or drinks alone. When alcohol enters her bloodstream and that of her fetus, it reduces activity in both their central nervous systems. What are the implications for the fetus when the mother drinks during pregnancy? Alcohol use during pregnancy may prime the woman's offspring to like alcohol and put them at risk for heavy drinking and alcohol use disorder during their teen years. In experiments, when pregnant rats drank alcohol, their young offspring later displayed a liking for alcohol's taste and odor. How does maternal drinking affect the fetus? Even light drinking or occasional binge drinking can affect the fetal brain. Persistent heavy drinking puts the fetus at risk for dangerously low birth weight, birth defects, future behavior problems, and lower intelligence. What is fetal alcohol syndrome? For 1 in about 700 children, the effects are visible as fetal alcohol syndrome, the most serious of all fetal alcohol spectrum disorders, marked by lifelong physical and mental abnormalities. What adaptive reflexes is the newborn equipped with? So, moving into the next section of the lesson. When something touches their cheek, babies turn toward that touch, open their mouth, and vigorously reach for a nipple. Finding one, they automatically close on it and begin sucking. Other adaptive reflexes include the startle reflex. This is when a newborn has their arms and their legs when they spring out really fast, followed by a fist clenching and a loud crying, and the surprisingly strong grasping reflex, both of which may have helped infants stay close to their caregivers. So here is a chart of infant reflexes. These are all innate. The rooting, that's when something is touch the baby's corner of the mouth, and they turn and they're looking for food, usually the mom's breast or the bottle, to begin feeding, and that lasts until about 4 months. The sucking reflex, so when the roof of the baby's mouth is touched, the baby will begin to suck because that's how they know that there's either a mom's nipple or food, or a bottle rather, signifying food. The grasping reflex, stroking the palm of the baby's hand, the baby will close their fingers in a grasp. The startle reflex and the Babinski reflex, that occurs after the sole of the foot has been firmly stroked. The big toe then moves upward or toward the top surface of the foot, and the other toes fan out. What is habituation and how is it used to study infants? So decreasing responsiveness with repeated stimulation. That's habituation, they become used to it. As infants gain familiarity with repeated exposure to a stimulus, their interest wanes and they look away sooner. The novel stimulus gets attention when first presented, but with repetition, the response weakens. Seemingly boredom with familiar stimuli gives us a way to ask infants what they see and remember. Maturation is when biological growth processes that enable orderly changes in behavior relatively uninfluenced by experiences. That is, biological growth not influenced very much by experience. How does the brain develop during infancy? So in humans, the brain is immature at birth. As the child matures, the neural networks grow increasingly complex, and this diagram is awesome. You can see the neural networks. There aren't very many connections as a newborn. And then if you move to 3 months, there are many more connections, neural connections, meaning learning has happened and synapses have formed. and then up to 15 months, look at that intense growth compared to a newborn. What does the research show about brain development in infancy and childhood? So this rapid development helps explain why infant brain size increases rapidly in the early days after birth. From ages 3 to 36, the most rapid brain growth was in frontal lobes, which enable rational planning. During those years, the child brain requires vast amounts of energy. The energy-intensive process caused rapid progress in your ability to control attention and behavior. So association areas. Cute little baby picture. The brain's association areas are those linked with thinking, memory, and language. These were the last cortical areas to develop, and mental abilities surged. How do we form and prune neural connections? So fiber pathways supporting agility, language, and self-control proliferate into puberty. Under the influence of adrenal hormones, tens of billions of synapses form and organize, while a use it or lose it pruning process shuts down unused links. So note that maturation, to developmental psychologists, is a biological sequence. This is much more precise than the general notion that maturation means to become more adult-like. I'm not saying like maturing means, oh, you grow up and you're not, making fart noises or engaging in unnecessary drama or things like that. This is developmentally, meaning biological sequence of maturing, biologically. All right, so what's the sequence of motor development? So sit, crawl, walk, run. The sequence of these motor development milestones is the same around the world, though babies reach them at varying ages. Is age of walking guided by nature or nurture? Genes guide motor development. In the United States, 25% of all babies walk by 11 months of age, 50% within a week after their first birthday, and 90% by age 15 months. So it's really important not to compare because everybody's different and develops at a different rate. So last, does nurture also play a role in learning to walk? Nurture may amend what nature intends. In some regions of Africa, the Caribbean, and India, caregivers often massage and exercise babies, which can accelerate the process of learning to walk, which is so cool. What does research show about our ability to retain early memories? So studies suggest that we consciously recall little from before age 4. We talked about that in our last lesson. Mice and monkeys also forget their early life as rapid neuron growth disrupts the circuits that stored old memories. But as children mature, infantile amnesia wanes and they become increasingly capable of remembering experiences even for a year or more. The brain areas underlying memory, such as the hippocampus and frontal lobes, continue to mature during and after adolescence. Do infants have nonverbal memory? Researcher Carolyn Rovey-Collier observed nonverbal infant memory in action. Her colicky 2-month-old Benjamin could be calmed by moving a crib mobile. Weary of hitting the mobile, she strung a cloth ribbon connecting the mobile to Benjamin's foot. Soon he was kicking his foot to move the mobile. So, can babies learn? Rovey-Collier realized that, contrary to popular opinion in the 60s, babies can learn. To know for sure that her son wasn't just a whiz kid, she repeated the experiment with other infants. Sure enough, they too soon kicked more when hitched to a mobile, both on the day of the experiment and the day after. How does Rovey-Collier's research demonstrate infant learning? If, however, Rovey-Collier hitched them to a different mobile the next day, the infants showed no learning, indicating that they remembered the original mobile and recognized the difference. Moreover, when tethered to the familiar mobile a month later, they remembered the association and again began kicking. What additional evidence demonstrates learning in infants? One study tested English-speaking British adults who had no conscious memory of the Hindi or Zulu they had spoken as children. Yet up to age 40, they could relearn subtle sound contrasts in these languages that other English speakers could not learn, which is pretty cool.